Okay, so a scatter plot displays the direction, form, and strength of a relationship between two quantitative variables. Linear relationships are particularly important because a straight line is a simple pattern that is quite common. A linear relationship is strong if the points lie close to a straight line, and weak if they are widely scattered about a line. Unfortunately, our eyes are not that good of judges of how strong a linear relationship is. Since they're hard to judge, we have what's called a correlation. And a correlation is the measure that we use to judge how strong the relationship is. So, how do we measure the strength of a linear relationship between two quantitative variables? We measure the strength of two quantitative variables with correlation R. Correlation R measures the direction and strength of the linear relationship between two variables. Correlation R is always a number between -1 and 1. Correlation indicates the direction of a linear relationship. If R is greater than 0, meaning positive, then it's going to be a positive association, where if R is less than 0, meaning that it has a negative value, then it's going to have a negative association. Values of R near 0 indicate a very weak linear relationship. The strength of a linear relationship increases as R moves away from 0 in either the negative or the positive direction. Extreme values, R equals a -1 or R equals 1, occur only in a case of a perfect linear relationship, when points lie exactly along a straight line. Okay, so what are some characteristics of correlation? Correlation R is always a number between -1 and 1. If R is greater than 0, the relationship is positive. If R is less than 0, the relationship is negative. The closer R is to 0, the weaker the relationship, and the closer it is to 1 or -1, the stronger the relationship. Is outside the pattern of the rest of the data. The new correlation is R equals a -0.88, much stronger. What effect would removing the student 9.4948 have on the correlation? Okay, so it would make the correlation closer to 0, since this point is in line with the rest of the data, and is particularly influential since the x value is larger than any of the others. The new correlation is R equals a -0.66. Can we determine the form of relationship using the correlation? Well, the correlation really gives us the direction and the strength of the association, not the form. Is correlation resistant to the measure of strength? No. We saw that if we removed an outlier, that it changed the strength. Okay, suppose that we have data on variables x and y for n individuals. The values for the first individual are x1 and y1. The values for the second individual are x2 and y2, and so on. The means and standard deviation of the two variables are x bar and sx, and for the x values, and y bar and sy for the y values. And this is the correlation. R is equal to 1 over n minus 1, and so on and so forth. Or R is equal to 1 over n minus 1, and the sum of xi minus x bar over sx times yi minus y bar over sy. It's a pretty complex formula, but fortunately we can find R using our calculators. Also, this formula is on your AP sheet, on that formula sheet for AP exams. So that's a good thing too. You don't have to memorize it. Now would be a good time to stop and check your understanding on page 154 and 155. Okay, so for A, the correlation is about zero point 0.9. There's a strong positive linear relationship between the number of boats registered in Florida and the number of manatees killed. B, the correlation is about 0.5. There's a moderate positive linear relationship between the number of named storms predicted and the number of named storms. C, the correlation is about 0.3. There is a weak positive linear relationship between the healing rate of 2 front limbs of the newts. D, the correlation is about a negative 0.1. There's a weak negative relationship between last year's percent return and this year's percent return in the stock market. Okay, so in the scatter plot in B contains an outlier. The disastrous 2005 season, which had 27 named storms, including Hurricane Katrina. What effect would removing this point have on the correlation? And explain. Well, the correlation would decrease. This point has the effect of strengthening the observed linear relationship we see. These are some facts about correlation. How correlation behaves is more important than the details of the formula. There are some things that you need to know in order to interpret correlation. First of all, correlation makes no distinction between explanatory and response variables. It makes no difference which variable you call X and which one you call Y when you're calculating the correlation. You can see in this formula why that's true, because it doesn't matter if I multiply this times this or multiply this times this. It's the same number. So it doesn't matter which order it is. It doesn't matter which variable is X and which variable is Y. Because R uses standardized values of observation, R does not change when we change the units of measurement for X, Y, or both. In other words, measuring height in centimeters rather than in inches and weight in kilograms rather than in pounds does not change the correlation between height and weight. And third, correlation R itself has no unit of measurement. It is just a number. Describing the relationship between two variables is more complex than describing the distribution of one variable. Here are some cautions to keep in mind when you use a correlation. Correlation requires that both variables be quantitative so that it makes sense to do the arithmetic indicated by the formula for R. We cannot calculate a correlation between the incomes of a group of people and what city they live in, because the city is categorical. Correlation measures the strength of only the linear relationship between two variables. Correlation does not describe curved relationships between variables, no matter how strong the relationship is. Like the mean and standard deviation, the correlation is not resistant. R is strongly affected by a few outlying observations. Use R with caution when outliers appear in a scatter plot. Correlation is not a complete summary of two variable data. Even when the relationship between the variables is linear, you should give the mean and standard deviations of both X and Y along with the correlations.